Welcome back. Today we're going to be looking at pandas in Python. So what are pandas? Well, pandas is something else that you can get in Python which will help you a lot with your code. So it stands for panel data and Python data analysis. It's kind of two things at once. It's a Python library for working with data sets, and it can do a lot of cool stuff. So why would you use pandas? Well, it's very clean. It sorts out a lot of things that if you were to use a spreadsheet, you might get errors with. There are some built-in functions that make it very useful to use. It's a very important framework in data science, so lots of data science applications use pandas, and it's open source. So you can in fact contribute to it in the same way you can contribute to Numpy. So let's go and play with it. So before we do anything, we need to install pandas. Just type in pip install pandas, and it will download all the necessary files. You can see that I've already got everything installed, so I don't need to worry. So we'll start by importing pandas, and we'll call it PD, which is the classic way. And we also want to import Numpy, because pandas is based off of Numpy. And so we're going to be looking at this sample CSV file. It's got a bunch of baseball players in. And so we'll start by reading the file. And so we'll create a data frame, which is usually called df, and that's equal to pandas, and then they have a read CSV function, and the CSV name is sample.csv. So now we'll print out the data frame. And you can see it's printed out our data frame. But you can see there are 1,034 rows, so it hasn't printed out everything. So if at any point we want to print out just the top, then we print the head. And if we ever want to print out just the bottom, we print the tail. And you can see it's printed the first 5 and the last 5. If we also want to display information about the data frame, then we can print the info. And you can see it tells us that it's a data frame. It's got 1,034 entries from 0 to 1,033. They've got columns, 6, and all of these columns are non-null, and it gives you the different types. And you can also see exactly how much memory it's using. If we also want to get a sample, then we can actually just get a sample and say that n is equal to, let's say, 10, and it will print out 10 items. And you can see it's randomly picked 10 indices and printed out all the details. So the first thing I don't like is that the height is in inches. So we should probably change it so that it's no longer in inches. So we'll take the height in inches, which is the name, and we'll multiply it by 0.0254. So now it's in meters. And so we probably want to then rename the column. So we set the data frame to a new data frame where we've renamed the columns. And the columns are the height in inches, just becomes the height. And if we do that, and we'll print the height and see what it's done. As you see, now we've got all these values. We probably don't want the height to have 4 decimal places, so we can change that by saying that the height is equal to the height. We just round it, and we set the number of decimals equal to 2. And you can see now it's rounded everything to 2 decimal places. I also think we should do something similar with the weight to convert it to kilograms. So maybe here, as well as renaming the height, we'll rename the weight, which is currently in pounds, to the weight. And so now we'll print the weight, but we want to change it first. So we want to say that we multiply the weight, and this time the conversion factor is this. And you can see for the weight, we've got some new values in kilograms, but that's a lot of decimal places, and we probably just want it rounded to the nearest kilogram. So we can use Numpy to do that. So we set the weight equal to the weight, and what we want to do is want to apply the Numpy round function. We could use the round function again. This is quite a nice way of doing it. And then we want to set it to be a certain type, and that type is int 32. So we've rounded it and converted it to an integer. And you see that's worked. But if we print out our original data frame again, you can see it's also got the age to 2 decimal places. So we should probably change that so that it's an integer as well. And we can use the same line. And that looks a lot nicer already. Another thing you can do with data frames is you can get correlations. So we can now print the correlation for the data frame. And you'll see that this gives us back a table where it tells us the correlation of each item with each other item. So you can see everything correlates with itself perfectly. And generally, there's a small correlation between age and weight, and a small negative correlation between height and age. But weight and height are reasonably well correlated. So that's why it's a useful tool in data science. Another thing that I think we can do is convert the name into first name and surname. We'll say that the first name is again equal to the name, but we want to apply a function, and this is going to be an anonymous function where we take it, we split it, so where the space is, and it gets a list, and then we take the first thing in our list, which is the first name, and save that. And we can do the same for the last name, except that with the last name we want the last thing. And this does mean if they have any middle names they'll be lost, but that's not that much of an issue. And again, we can print the data frame. However, now we've got the name, the first name and the last name, so we probably want to delete the name. So we've just got the first name and the last name. There we go. So now it would be nice if we could save it. So rather than printing it out each time, we're actually going to save it to an Excel spreadsheet. So we use the df to Excel, and then we just put the name in. So if we call it players.xlsx, we run that, you can see that a players.xlsx file has appeared. And we can open it. And you can see that we've got the team position and all the details, and we've got different columns telling us the index. So we want to edit it, so we've actually got to close it so that we can edit it. And I think the first thing that we want to do is get rid of the index. So we can just say that index is false. And now it's deleted the index. However, I think that we can do better. So instead of saving the whole thing to an Excel spreadsheet, we're going to save each team to a different sheet. So what we should do is, we should probably first get the teams. so that we know what each sheet will be called, and we can say that df.teams.unique, so it only takes the unique values, and we can see what the teams are, except that each of them is called a team rather than teams. And you can see these are all the teams. So now we need to create an Excel writer. So we use the Excel writer, and the file name is players.xlsx, and we'll call that writer. We'll loop through the teams, and we'll say that the team data frame is, and then we're going to use the Numpy function where to find out the correct team. So what we'll do is work out where the team of each part of the data frame is equal to the team. So we're saying we only select the values where the team value is the same as this team, and then we use the df.lock to find that. And this is a way of locating stuff with kind of strange indexes. This would just be a list of true or false values. And then we convert this new df to Excel, and we put in the writer. And we'll set the sheet name equal to the team, and again we'll set the index equal to false. And then we can run that. And we open the players and see we've got each team in a different sheet, which is really nice. I also think though, maybe we should sort it before we save it to Excel. So at this stage, after we delete the name, we'll sort the values. And we need to say what we're sorting by. And then the way it works is we say sort by team first. And then we say if they're in the same team, sort by position. And if they're in the same team and they play in the same position, then sort by their last name. And if all three of those are true, then sort by the first name. And you can see here it's sorted by the position, and then by the last name, and then first name. However, I think one of the features Excel has is that you can have a table, but we currently don't have one of those. It's just some rows and columns of values. So we'll actually put in a table. First thing we need is some settings, and currently it's just an empty list. And then we need to loop over the columns, and we want to add to the settings something that says the header is, and then the column, so that we've got all these headers in our table. And then we want to select the current sheet, so we'll say that the work sheet is, and then we go to the writer.sheets, and we want to select the team. And we know that it exists because we've just created it, so we don't have to worry about that not working. And then we need to get the size, and that's the team data frame and its shape. So that counts how many rows and columns it's got. And then we want to just add a table. And we start in the top left corner, and then we have the same number of rows. We need to subtract one from the columns because we've taken out the index, and we need to say that the column names are the settings. And you can see this time I've left it open, and it's given us this error saying that it can't edit the file. And now we've got a nice table. However, I think there's one last thing to do, and that's these are really narrow, which make it quite hard to read. So I think we should redo it, but make them wider. And so we can just set the columns and go 0, and we need one less column because we've taken away the index, and then 12 because 12 is a good width to have. And I'm actually going to delete the spreadsheet so that this time the names appear in alphabetical order. And for some reason that hasn't worked, but it's not that much of an issue. You can see it's widened all our columns. We've got all our teams in a different sheet, their ages and height to the correct value. You notice we're missing a 0 in some of these, and that's Excel doing stuff that's a bit annoying. And if you keep it in a data frame or write it to a CSV, then you don't have to worry about that. And that's one of the reasons Pandas is so powerful, because it won't convert stuff into unnecessary formats. So if you, for example, had a name with a slash in, it might try converting it into a date, which would be a bit worrying. But you can see this is a very powerful tool to use. Hopefully you kind of have a flavour of what Pandas is like, and I'll see you again same time next week. Till then.